All right. So, hello everyone. This is the third lecture on avionics. In this video, we will be discussing about the different display units which you can find in an aircraft. So, we'll study about the different technologies of display units, and then we will also discuss some of the uh, common input and output devices. And also we have studied this the heads up display and all those type of display in the first lecture. So we will be discussing about them in detail in this lecture as well. Now, the modern aircraft, uh, it has different types of display technology. So in the aircraft, if you go into the cockpit, you will see different types of display units. So some of them, they are uh, cathode ray tube, that is CRT. Then you have light emitting diode or LEDs, and liquid crystal displays like LCDs, and electroluminescent display ELD, and plasma display as well. So the display which you find in the cockpit, they include all these different display technologies. Now let's start with the first one, which is the cathode ray tube, and it is the oldest display technologies. I'm not too sure, but you might have seen those big televisions, right? Big and bulky television, old televisions. So they used this technology to display the pictures, the videos which we used to watch. So the CRT, it consists of cathodes. Okay. It has some heating element surrounding the cathode and a grid or a mesh. Along with that, it has an assembly of different anodes. Okay. So the heating element or the heater around your cathode, it will heat the cathode. Right. So cathode, they are coated with tungsten. Okay. So your cathode, they are coated with tungsten. Okay. So tungsten is the same element or the material which is used in light bulbs. Okay. So similar to that, your cathode is also coated with tungsten, and when it is heated, it will emit electrons. Okay. So your cathode, they will emit electrons. Now you have the grid or the mesh. Okay. So grid is made out of fine wire mesh. Okay. So grid is basically your fine wire mesh. So something like this type of a mesh. Okay. And they are negatively charged. Okay. So your cathode, they emits electron, and they are surrounded with, so it's something like you have your cathode here, and it is surrounded with a mesh. and these are also negatively charged. So what they will do is they will repel all the electrons out of this mesh. Okay. They repel all the electrons out of this mesh. So at this point you will have a beam of electron coming out of this cathode and grid assembly. Okay, then you have some focus or focusing anodes. Okay, so these focusing anode, they are positively charged and they will attract the electron, and they have a small slit or a gap in the middle, right? They have a small gap in the middle through which the electrons in form of a beam, it will come out, right? Focusing anode, so it will focus the electrons which are coming out. Okay, then you have accelerator anode. So accelerator anode, it gives speed or acceleration to the beam of electrons, right? So focusing anode, focus the electron into a beam. Okay, they will focus the electron into a beam. Accelerator anodes, so they are again positively charged. So all the anodes, they are positively charged, and accelerator anode, they will accelerate the electron beam. Okay, they will provide speed or acceleration to the electron beam. So they all use different potential or different value of positive charges to pull the electron out, focus it into a small beam, and then provide acceleration. Okay, then we have X and Y plate. So basically you have this beam of electron which is coming out. Okay, and then you have a fluorescent screen. Okay, so to focus or to hit the screen at different point, you have to adjust the beam along X and Y direction, right? So for example, you have this screen, right? So to focus the electrons here, then here, then here, you have to adjust the electron beam along X and Y direction. Okay, so these X and Y plate, they will adjust the electron along the X and Y direction. Okay, and the screen, so this screen, it is coated with a fluorescent material. So when an electron beam hits the screen, it will glow or it will emit some form of luminance or light. Okay, so that's how your cathode ray tube, it works. And here is an animation to demonstrate the basic working of your CRT. Okay, you have so basically we apply a negative potential, and of course you have the cathode, the grid assembly here. Okay, and because of this potential difference, you get electrons. They are emitted. Okay, and this is your focusing anode. Okay, which will form a beam of electrons. And then you have these X and Y plates. So generally you have some electrodes where you apply electric field to adjust the beam along the Y direction, and then we use magnetic field to adjust the electron along the X direction. Okay, and whenever it hits this fluorescent screen, light will be emitted. Okay, so depending on the electric and magnetic field, you can adjust the direction of the electron beam. Okay, now the screen, so in case of colored CRT, so to produce different colors, the screen is coated with a pattern of different phosphors, right? And different phosphors, they will produce different color, right? CRT, basically we use three different phosphor materials, right, which produce the red, the green and the blue, which are the fundamental colors of light. Okay, and depending on the intensity of the electron beam, different colors can be produced, right? So basically, if you want to produce a yellow color on the screen, you can combine the green and the red. Okay, no electron will be hitting the blue dot or the blue phosphor area. Okay, so that's how you can produce different colors on the screen. Okay, and of course in a colored CRT or cathode ray tube, you would need 3 beams of light, of electrons. Okay, so similar to the last slide, we explained only a single beam of electron. In case of CRT, you would need 3 beams of electron, which will be hitting the 3 dots or phosphor dots. Okay. The next type of display is your liquid crystal display, or in short we call it LCD. Okay, so LCD, they are liquid crystals. Basically they have properties somewhere between solid and liquid, right? So they are neither solid nor liquid. They have a property in between. Now these LCDs, or sorry, the liquid crystals, they have some material. So basically you will have some crystals inside your solid. And what happens is, when we apply a potential difference or a voltage, these crystals, they align themselves in a certain manner. Okay, so initially when no voltage is applied, these crystals, some of them are like this, some in a random manner they are arranged. Okay, like that. And when you apply a voltage, all these crystals, they will align themselves in a certain fashion. or in a certain manner. Okay, and that will and when a light is incident, or from the back if you shine a light, the lights they get because of polarization effect, the incident light will either produce a dark or a bright spot. Okay, so that's how your LCD they work. So as you can see in the animation, when you apply a voltage, the crystals they get aligned, and when this ray of light it is uh, it is then allowed to pass through that liquid crystal, it produces a dark spot. And similarly, if they are aligned in a different manner, those crystals they are aligned in a different manner, they will produce a bright spot on the screen. Okay, so these LCDs they cannot produce light of their own, they will need a light source, right? So LCDs they need light source to operate. Okay, and similar to this single LCD, you will have multiple LCDs on the screen. Okay, that will produce a complete picture. So that will produce some dark spots, some bright spots, and overall it will produce an image or whatever data you are trying to produce, something like here. Okay, so it will produce different dark and white spots. So there are basically reflective LCD which use incident light, and you have backlight LCD which use own light source. Okay, now LCDs they can be of active and passive matrix display. So passive matrix display use matrix of conducting electrodes to provide voltage across the liquid crystal. So this is your passive matrix display. So in this you can see you have some conducting electrodes. Okay, so one in the front and one in the back. Okay, so you have this type of a matrix of electrodes in case of passive matrix display, and these provides the voltage which you need to align the crystals in different orientations, okay, or in different directions, right? So this improves the display quality and it can be used to display text, graphs. But the issue with this passive matrix display is it is slow. Okay, it is quite slow, and also the quality of display is not sharp. Okay, display quality is not sharp. Okay, you don't get very sharp pictures. Okay, the next type of display here, or next type of LCD display, is your active matrix display. So they use transistors which are fabricated on the glass substrate. Okay, so On the glass itself, you fabricate transistors. Okay, so transistors are fabricated on the glass substrate, and inside this, so this you can assume it to be a cell or a chamber, and inside this you have your liquid crystal. Okay, liquid crystal which is filled inside this glass tube, or you can say glass cell, and you have the transistors fabricated on those glass substrate. So transistors, they will act like switch, and they will turn on and off that cell. Okay, so you can say cell, or you can say glass cell filled with liquid crystal, and transistors fabricated on glass, which acts like a switch. Okay, so it will switch on and off different cells on the screen to produce a dark and a bright spot on the screen to display your image or whatever data you are trying to display. Okay, so we use thin film transistors, so these will be transparent. Okay, and along with that we can use some color filters. Okay, so we can use some color filter to produce a colored image. Okay, so color image in LCDs, they are produced by using color filters. Okay, light emitting diode. So LED is basically an electronic device which is made out of semiconductor materials. Okay, so semiconductor, so these, I'm sure that you might have already read about semiconductor materials and LEDs at some point. So semiconductor materials, basically they act like both conductor as well as insulators. So when we apply a certain value of voltage across that material, semiconductor material, it will start conducting. And if the voltage is less than the required voltage, then it will act like a insulator. It will not allow the electricity to pass through it. Okay, so basically we use two types of semiconductors, P type and N type. Okay, so using this we can develop an LED. So semiconductor materials, they are also used in fabricating electronic devices, something like your transistors, then your diodes. All these, they are made out of semiconductor materials. Okay, and what happens is they form a barrier. Okay, as soon as you combine these two types of materials, semiconductor materials, they will be a barrier. Okay, that is why you need a certain value of voltage to break this barrier. Okay, so P type semiconductors, they have more number of positive charge, and N type semiconductor, they have more number of negative charges. So when you join them together, the positive and the negative charge, they will combine together. okay, at this junction and produce a neutral charge, right? When you combine one positive charge and one negative charge, they combine together and become a neutral. So that is why at the junction you will have more concentration of neutral charges. Okay, neutral charge, which restricts further flow of uh, charges or electrons. So we need some voltage to break this barrier or this barrier at the junction, right? So if we use a certain type of semiconductor material, some of them, they have this property that when this junction will break, they will emit some electrons, some uh, light energy. Okay, so such type of materials, they are used in LED. Okay, and the color of the light, right? The color of the light, it will depend on the semiconductor material. That you are using. Okay, so some of the semiconductor materials, they will produce a red colored light. Some of them, they will produce a blue colored light, and the others may produce a green colored light, right? So we use three colors of light: red, blue and green, okay, to produce all the other different shades or different colors on the screen. Okay, so these LEDs, they can be used in displaying a number, something like in 7 segment display. Okay, so where you have 1 2 3 4 5 6 7 LEDs. Okay, and using this combination of 7 LEDs, you can display numbers from 0 to 9. Okay, so these are used to display numbers from 0 to 9. Okay, or you can display an image or pictures using an array or combination of these red, blue and green LEDs on the screen. Okay, and depending on the intensity of the light, you can produce different colors, other colors also on the screen. Okay, so on the LED screen, we use an array of red, green and blue LEDs. Okay, and obviously these LEDs, I think nowadays they are quite popular as well. So these LEDs, they can be used to display some high quality or very sharp pictures. Okay, the next type of display is your electroluminescent display, right? So this display is created by sandwiching a layer of electroluminescent material, something like gallium arsenide. Okay, between two layers of conductor. Okay. So there are some materials, something like gallium arsenide, which has this property of electroluminescent. Okay, luminescent means, you can, generally speaking, it means the property of producing light. So electroluminescent, it means when some electrical property or maybe some voltage or current or electric field is applied to this electroluminescent material, they will produce some light. Okay, so basically it has two, conductive and transparent. Okay, so these two layers are conductive and transparent. Otherwise, even if the electroluminescent material, it is producing some light, you won't be able to see it. So the two layers should be conductive as well as transparent. Okay, so generally in layman terms, if I say, we use glass slides or glass which are coated with titanium or something, which makes it conductive as well. Okay, so you take a glass slide and you coat it with some conducting material, a thin layer of conductive material. So along with conducting the electricity, it will be transparent as well. Okay, so when current flows through the layer of material, it emits radiation in form of visible light. Okay, so when current, it flows through this material, some light radiation is produced. Okay, the emitted light is a result of radiative recombination of electrons and holes. Probably in chemistry or something, you might have read about this recombination of electrons and holes. So conduction band and valence band electrons, right? Conduction band and valence band. So when we apply a current, the electrons from the valence band, they go into conduction band, or higher, they attain a higher energy state. Okay, when you apply the current, and after staying in the higher energy level for some time, instead let me call it lower energy and higher energy level. Okay, just to explain you in general sense. So when we apply current, the electrons from the lower energy level, they will go into the higher energy level. It will stay there for a while, and then it would obviously like to return back to its lower energy state. Okay, something like us also, we always, like humans also, we like to relax, sit all the time, don't do any work, right? Even if we are going for work, after completing the work, we would like to return back to home and just relax in the lower energy state. So similar is the property of your electrons as well. Okay, they always like to attain or go back to lower energy state and just relax. Okay, so after staying for some time, it would like to return back to lower energy state. and whatever extra energy it is having, it will emit in form of radiation. Okay, and that radiation, in case of electroluminescent material, it is in visible radiation. Okay, so light is also radiation. Okay, so it is visible radiation. Human eyes can see those radiations or those spectrum of radiation. Okay, so basically, in simple words, when you pass the current through this electroluminescent material, they produce light. Okay, and that is used in these type of display. The next type of display is your plasma display. Okay, so this display uses small cell. Okay, they use small cell containing electrically charged or ionized gas. Right, so you have some small cell which is filled with ionized gas. Okay, and then we use some transparent electrodes. Okay, so we use some transparent electrode. Transparent electrodes. Okay, on either side of the cell. Okay, here also you can imagine it or you can view it in 3 dimension. Okay, and when you apply a voltage across these 2 electrodes, what will happen? You will produce some kind of a spark. Okay, so whenever you have 2 wires very close to each other, obviously you can imagine that they produce some kind of spark. Okay, and spark or that particular is UV light. It has some ultraviolet light emission. Okay, so whenever we apply some light, some UV light, whenever we apply the voltage, some UV light is produced across the electrodes, and this UV light is then absorbed by the phosphor. So these cells, they are coated with some phosphor material. Okay, you can see it here also. So these cells, they are coated with some phosphor material. So what will happen is, whatever UV light it is producing, it will be absorbed by this phosphor material and produce a colored light. Okay, to produce different color of light. Okay, the working is quite simple. You have 2 electrodes and they will produce some UV light when voltage is applied, and in between you have a cell which is filled with ionized gas, and the inside is coated with some phosphor material. Right, so those UV light will be absorbed by the phosphor material and produce some colored light. Okay, let's have a look at this animation. So as you can see in this animation, we have two wires which are very, or two electrodes which are very close to each other, and in between you have a very thin cell, and since they are very close to each other, they will produce some spark or some UV light will be produced in between them. Okay, and we place a thin cell containing ionized gas and phosphor, coated with phosphor material. Now filling these cells with ionized gas, it is for a reason, right? So if you fill the cell with ionized gas, it will conduct those spark or those UV light. It will allow the UV light to enter into the cell, and that is what we want. Okay, so something like during the rainy season, let's say when the outside temperature is very hot, okay, let's say during the day it was very hot, and then in the evening or in the night it starts to rain. Okay, so in that condition you will definitely have some lightning. Okay, because during the day the air was heated and it got ionized. Okay, and that allows the spark generation, or you can say the lightning, to happen. Okay, so that is why we need that ionized gas to kind of attract the UV radiation into the cell. So those were all the different types of display technology which you can find in your aircraft. The next is some different types of touch screens which we use in the aircraft. So the first one is resistive touch screen. Okay, so the resistive touch screen, or RTS, it consists of an electrically conductive and resistive layer, okay, which are separated by thin spacers. So these are your spacers. Okay, these red dots, they are your spacer. And when we touch or press the screen, the layers are connected at certain point. Okay, so you have a thin plastic sheet or whatever, and then you have a conductive layer which are separated by spacers, and when you press on the screen, the flow of current will start, right? So when you touch the screen, it causes a change in electric current, and depending on the value of electric current and different parameters, the selected function is displayed after processing. Okay, so generally in resistive displays, you will have the screen will be consisting of multiple resistive touch screen. Okay, so let's say you have feature number 1, or maybe some music, right? I'm just talking in general sense. You have a function to for playing music, maybe some videos or camera, right? So if you press this one, the current will be obstructed, or there will be change in current and a particular video will start playing. Okay, or this particular feature will be selected. Okay, so the concept or the working of this resistive touchscreen is quite simple. You have basically I've already explained it. You have a conductive and a resistive layer. When you touch it or when you press it, the layer will come in contact, right? And the current will start flowing, right? So you have the conductive layer separated by some spacers. When you touch it, they will come in contact and current will start flowing, and that will select the particular feature or the function. So some of the advantages of this resistive touch screen is they are more affordable and they are quite commonly used. Okay, and since they have this type of a plastic film or coating on it, so they are quite rugged. That means they will not be affected by dust or water, okay, or rain. So they can be used in different environmental conditions. The next type of touchscreen technology which is used is your surface acoustic wave, or SAW in short. So these surface acoustic wave, how they are produced is basically on, let's say, a glass substrate, you print some conducting strips very close to each other. Okay, very close to each other. Okay, and the same thing we do it on the other side. Okay, and when we apply some voltage or some potential across these two electrodes or these set of electrodes, a wave is produced. Okay, now the property of this wave is that it will travel on the surface. Okay, it will travel on the surface of this substrate, right? Not through the substrate, it will travel on the surface. Okay, and if you are touching a certain portion or at a certain place, the surface acoustic wave or these waves, they will get reflected back and you will not receive any wave on the other side. Okay, so depending on the amount of wave which is reflected and not received on the other side, you have to obviously use some programming to identify the location of the touch. Okay, so these surface acoustic wave, they are basically electromagnetic wave which travel on the surface. Okay, surface of the glass substrate, and when the panel is touched, a portion of wave is absorbed or reflected, and this information is sent to the controller to display the selected function. Okay, The other type of touch screen technology is your capacitive touch screen. It's the simplest. So basically you have two conducting plates, right? So you have two conducting plates. Let me draw my own picture. Okay. Conducting plates, and the value of capacitance, it depends on the distance between the plate. Okay, this distance. Okay, and if you press on one of the plates, let's say if you press on it, the distance between the plates, they will reduce or they will change, and that will change the value of capacitance. Okay, and depending on the value of capacitance, you can then select, you can use it to display that selected feature. Okay, so capacitive touch screen panel, it uses two plate coated with indium titanium oxide. So obviously these conducting plates should be conducting as well as transparent. Then only you will be able to see what is what information is being displayed on the LED, LCD, or whichever display you are using. Okay, so behind this you have your display. Okay, and on top of your display you place this touch screen technology. Okay, so these should be transparent as well. Okay, transparent and conducting. So to make them transparent, we use glass, and to make them conducting, what we do is we coat these glass with indium titanium oxide. This material, it will make it conductive. Okay, and when the screen is pressed, the capacitance between the plate, it changes. Okay, and this change in capacitance is then sent to processor to display the selected function. Okay, so again, on your display you will have multiple capacitive touch screen. Okay, so you can display different functions here, and whichever function you are pressing, that will be selected. The next type of touchscreen technology is optical imaging. Okay, so from the diagram here you could imagine, so on both the sides, the left and the right side, you have your light strip. So we have a strip of light which is producing light on the screen. Now this light can be visible or it can be infrared. Generally we use infrared light, IR light, infrared, so which is not visible to the human eyes. Okay, and if you are touching anywhere on the screen, the light which is coming here, it will be then reflected, and depending on the angle, on the top you have optical sensors. Okay, on the top. So this can be either camera or infrared detector. Okay, and this will be reflected. So depending on the angle at which your light is being received by this camera or infrared detector, the location of the touch is found, and then you can display the selected feature or the function. Okay, so in this optical imaging touchscreen technology, we use two or more image sensors. They are placed on the edge of the screen. Infrared backlight, right? So these light strip, they produce infrared light on the back of the screen, or basically just a background. Okay, infrared backlight is placed in the camera's field of view. Okay, so this camera or this infrared detector is placed in such a way that it can cover the reflection of light from any point on the screen. Okay, and a touch shows a shadow, and the sensor are used to locate the touch. Okay, so the touch, they will produce a dark area or a shadow area, or it will reflect the light. Okay, as I was telling, and depending on the location of the touch, the selected feature is then displayed. Okay. Now, dispersive signal technology and acoustic pulse recognition, they are another two touchscreen technologies which are used. Just in brief, so in dispersive signal technology, when the screen is touched or pressed, some mechanical strain, right? So your screen will experience some mechanical strain, okay, or some mechanical energy will be produced in the glass. And using some sensors, we detect that mechanical energy in the glass. Okay, so if you like bend a little bit a piece of glass, you will hear some crackling sound. Okay, or if you press too hard on a glass sheet, you can hear some sound, crackling sound, isn't it? So that's your mechanical energy, right? Now by touch, the sound will be produced, or that mechanical energy will be produced, but it will be very small. Okay, but we have some sensors which can detect that small amount of mechanical energy. Okay, so using that and some complex algorithm, we detect the location of the touch, and the corresponding feature is then displayed. Acoustic pulse recognition is kind of related with the previous technology. So in acoustic pulse recognition, what we do is we convert this mechanical energy using some sensors into electrical signals. Okay, so using some sensors or transducers, we convert this mechanical energy into electrical signal, and then this electrical signal is then converted into audio or voice. Okay, and this voice is then or this audio is then compared to the pre-existing audio profile. So you can store the sound by pressing different location on that screen. You can store those sounds, and then later on you can compare whatever sound or audio is being produced with the pre-recorded sounds to find the location of the touch. Okay, so obviously these are quite complex technologies, and obviously you would need a storage space, some memory to store the pre-recorded sounds. Okay, and those sounds should be of high quality for comparing. Okay, so generally these technologies are there, but they are not very common in the aircraft. The next type of not display, but another type of data entry or input device which you can find is your direct voice input, right? So this direct voice input, it works on voice commands. Okay, so it enables the pilot to enter data and control the operations of the aircraft by giving some voice command. Okay. The spoken command and data are recognized by comparing the command with the stored speech template, right? So this voice command is then compared with a template. Okay, a template or a stored specimen of the command. Okay, it will be comparing with different voice commands. So something like lift up, okay, or increase the altitude. If the pilot is giving these type of command, so it will compare with the templates and identify the command, and then perform the operation accordingly. However, this voice input, it has some problem, or this voice recognition, it has some problems. So the words in vocabulary, they are limited if we are using voice recognition, right? So you can use only certain words to give the command. Okay, so the pilot has to remember all those specific word or keywords to give the command. Okay, and then you need those templates. So generating these templates and then storing it, it's not it's time consuming, as well as it will require some storage device on the aircraft. Okay, so again, adding any equipment on the aircraft will increase the weight of the aircraft. It will consume some power, so it will increase the cost of operation. Okay, and then obviously we, like different people, they have different accent, right? So it's quite difficult for the voice recognition software to kind of recognize different accent and then process the command. Okay, Then we have multifunction display. So multifunction display, it is a very small display or screen. So previously they used to use cathode ray tube or CRT, but nowadays we use like smaller, lighter LCDs in the aircraft, okay, which are surrounded by multiple buttons that can be used to display different information to the pilot on that small screen. Okay, so multifunction display is similar to you can say, just for comparison, you can say it is similar to the display nowadays on the cars. Okay, so which gives you all the information about the car on that display. Along with that, it also maybe displays the map. Okay, it helps you navigate as well. So you have a small screen with all the information you can find on that small screen. So since it is small, it does not consume much space in the aircraft, and multifunction display, it allows the pilot to display navigation route, weather radar data, ground proximity warning data, how close or you are to the ground. Okay, this one, and traffic collision and avoidance data. Okay, now the next type of display is your head-up display. So we have kind of discussed it in the first class, but let's now discuss how this technology it works, right? So head-up display, it is used to project the key information in front of the pilot, in the line of sight of the pilot, so that the pilot does not have to look down for information, or the pilot doesn't have to find the information from the different displays which are there in the cockpit, right? He or she can find the key information right in front of him, so that along with the information, the pilot will have awareness of the outside world, or he can continue to operate the aircraft without looking for information. Now, this heads-up display, as you can see in this diagram, every heads-up display, it contains a display generator, which can be either CRT or LED or LCD, and a combiner. Okay, and a combiner. Okay, so you have a display generator and a combiner. So the display generator, as I mentioned, it can be either CRT or LCD. Generally CRT is used, and the combiner, it consists of an assembly of mirror and lenses. Okay, mirror and lens. So what it does is, whatever display is producing, information the display is producing, it is reflected. So reflected image, it will be a mirror image, or if some text is being displayed, it will be swapped, right? So that's why we use a lens to revert it, right, to correct it in a proper manner. So if you use a mirror to display some text on the mirror, what you will see is it will be difficult to read, because left and right it gets swapped. Okay, so we use a lens to change the direction and then we project it on a glass. So glass is simple transparent glass which is partially reflective, right? And from this glass the information is then sent to the pilot, or it is being displayed in front of the pilot, so that pilot can observe the outside scene as well as the information. Okay, some of the key information which is displayed in heads-up display are primary flight information, navigation information, engine data, airframe data, and any warning information. Okay. The next type of display is your helmet mounted display. So again we have discussed it in the previous class. So similar to your heads up display, helmet mounted display is again used to display the key information in front of the pilot or in line of sight of the pilot. Okay, line of sight, okay, of the pilot. So basically your HMD or helmet mounted display, it uses a transparent LCD, right? So this helmet mounted display, it uses a transparent LCD, okay, which is mounted on the visor of the helmet. Okay, so this will allow the pilot to view the outside scenery and operate the aircraft, as well as the pilot can see the key information of the aircraft. So this type of display, it is generally used in fighter aircraft or in military aircrafts, as well as helicopters, right? In commercial aircraft we don't use it that often, or basically it is not used. In commercial aircraft you will use head up display. Okay, the next type of multi-function keyboard is your input device. Okay, the multifunction keyboard or MFK, it is an avionics subsystem through which pilot they interact or to configure the mission related parameter. So it is an input device, and using that the pilot can enter the mission requirements or the parameters. Okay, so for example, flight plan, airfield database communication equipments, and all other parameters, it can be set using this multi-function keyboard. So again, the purpose or the utility is it's very small, it has all the features on it, and therefore it does not require much space in the cockpit. So MFK, they consist of processors as well, right? Which includes your read-only memory. So ROM is read-only memory. So ROM is a memory device from which you can only read information. Okay, you cannot change that information, or you cannot write on that info. You can write on that memory. You cannot write on that memory. Random access memory. So this is random access memory. So in this you can read plus write. In this one you can only read. Okay, and then you have EEP ROM. So electrically erasable ROM. So basically in this you can read, write and erase all the memory. Okay, and then write it again. So it is rewritable, kind of rewritable memory. Okay, so MFK, it consists of all these different types of memory along with a processor, and it uses 1553B data buses for communication. We are going to study some of the data buses and all okay, in the future classes. And the MFK, it also has a display unit. Okay, so it has a display unit along with a keyboard. It's kind of a mini computer. Now, the last thing is your hand on throttle and stick. So you might have seen this type of a throttle in the aircraft, or generally in the military aircrafts as well as the helicopters as well. You might have seen it in commercial aircrafts also. You have this type of hands-on throttle and stick. Okay, so basically it has multiple buttons and switches on the throttle itself, which is used to control the speed and the direction of the aircraft. Along with that, you will have some buttons. Okay, and this allows the pilot to access vital cockpit functions and fly the aircraft without removing his hand from the throttle. Right. So if the pilot, so basically this throttle, on the throttle stick itself, you will have multiple buttons which the pilot can use to access the key functions. Okay, so it enables the pilot to fly the aircraft without removing his hand. Okay, otherwise if there are no buttons, the pilot may have to leave the throttle and then select a particular function and then come back to the throttle. So that may be a bit dangerous, or it may not be very convenient. Okay, so you have all the key functions on the throttle itself. So it allows the pilot to remain focused on the important duties and then look than looking for controls in the cockpit. Okay, so these were all the topics that I wanted to discuss in this class.